Dr. Harrison, a retired anaesthetist. Following on from the previous video, EDDI 1, I'm going to be talking today about how to assess whether a fall in blood pressure is significant. Run's analysis, as described previously, may indicate a trend in changing blood pressure, but the change may be very small. Not only will this be explained, but also how EDDI determines whether a hypotension alert should be generated. Just a note about EDDI. EDDI is a basic form of AI. It is deterministic. It does not rely on a large data set for its function. It cannot learn new processes, and it does not need an internet connection. It is therefore immune from hacking. This record of physiological changes shows how the blood pressure varies over time during anesthesia. The question is, when is a change significant? The first necessity is to determine the normal values of blood pressure during anesthesia, and then to determine what the normal changes are. Here we can see the blood pressure measurement, the red line, and the repeated calculated median value. At the far end, the red line stays above the median and suggests a trend. We know that a measurement has a 50-50 chance of being above or below the median, that is 1 in 2. For 2 values in a row, that is 1 in 4. For 3 values, 1 in 8, and for 4 values, 1 in 16. That could happen by chance, but the odds are quite high that it is a trend. If a trend has been detected for a change in blood pressure, it is necessary to know if the change is significant. Here is a graph of the changes in blood pressure that you can expect when the starting mean arterial blood pressure is between 90 and 99 millimeters of mercury, which is normal. During it 50 seconds later, you would not expect much change. Here it is about plus or minus 10 millimeters of mercury. Over bigger changes are possible. Here it could be plus or minus 20 millimeters of mercury. Here, the starting mean arterial pressure is between 120 and 130 millimeters of mercury. The body's homeostatic mechanisms are at work, and it can be seen that the expected range of blood pressure after 2 minutes is now plus 5 and minus 25 millimeters of mercury. So it is possible to estimate the boundaries of changes in blood pressure from a particular starting point. Here, the starting mean arterial pressure is between 50 and 59 millimeters of mercury. Knowing that homeostatic mechanisms are at work, it would be expected that the blood pressure would go up. As it does, after 2 minutes, the range is between plus 25 millimeters of mercury and 4 millimeters of mercury. It is now clear that by knowing the current blood pressure, we can make an educated guess at the next blood pressure. Here is a representation of that concept. Here, the current blood pressure is plotted against the previous blood pressure, and boundaries can be drawn indicating the spread of values. These values are at an interval of 10 seconds, which is the common refresh rate for variables for many anaesthetic monitors. Here the graph is redrawn with the current blood pressure minus the population average blood pressure, x-axis, and the change in blood pressure minus the population average on the y-axis. EDDI is built on changes in physiological parameters. Redrawn again, the axes are standard deviations. Knowing the current blood pressure, the change in blood pressure over the last time period, it is possible to determine the magnitude of the change in terms of standard deviations. So, EDDI determines a trend has taken place and then determines the magnitude of that change. Now to hypotension alerts. Intraoperative hypotension has a multitude of definitions, and hypotension, however defined, may be okay for one patient, but not for another. A healthy 20-year-old is likely to be more tolerant of hypotension than a 60-year-old with aortic stenosis. An alert for hypotension needs to be tailored to the patient. Anaesthetists vary in their estimation of their patient's tolerance, so a survey was carried out. In the survey, anaesthetists were asked when they would intervene if a patient's blood pressure, before anaesthesia, was in the region of 130/95 millimeters of mercury. How would they intervene when it started falling? They were given a whole series of scenarios, including age and some comorbidities. For example, moderate aortic stenosis. They were given a choice of tick boxes indicating the blood pressure at which they thought intervention was necessary. Here are the results of that survey regarding age. Take an example. An ASA1 patient aged 93, 80% of anaesthetists would intervene at a systolic of 100 millimeters of mercury. If it was a 21-year-old, they would intervene at 80 millimeters of mercury. As for comorbidities, the systolic blood pressure for intervention was variable. The severity of aortic stenosis certainly modifies the blood pressure of intervention. An intervention by the anaesthetist for the patient who has angina with exercise would be at a systolic blood pressure of about 100 millimeters of mercury, with a range of 100 to 110 millimeters of mercury. The EDDI alert, in plain spoken English, is of the form, this blood pressure may be too low for this patient. EDDI can detect hypovolemia by a combination of changing physiological parameters. The assessment of changes in blood pressure is by ascertaining that a trend has taken place and then the determining of the significance of that change in blood pressure. The assessment of a low blood pressure takes into account the age and comorbidities of the patient and was determined by a survey of anaesthetist views and practice.